Yeah, we are almost 15 years working comprehensive GC, so we did a lot, not only in food, but mainly in food. And for example, if I can give you an example, if we look to the volatile components of the coffee bean after the roasting procedure, and you do this analysis by GCMS, the best you can get, you can separate around 200 components. But if you use comprehensive GC with the non-polar and polar set in the second dimension, you can increase this number of components to around 1,500. So the most important point of this separation is that when you have, like in coffee, because due to the roasting procedure, you produce you don't have not only the components coming from the matrix, but you are producing new components due to the roasting procedure, and you have thousands of components. You need comprehensive GC to separate all of them. And also what is very important is that because you have two different stationary phases and the components, they are separated in both dimensions, I must say they have a unique position in the 2D space. And so components that are of the same family, for example in the coffee, the pyrazine, you have a very well ordered separation in the 2D space. So if you look in a specific region, you will see the pyrazine with the 2 carbon substituent. Or you look in another region, you have the pyrazine with the 3. So it's very well ordered. So even you don't use spectrometric or spectrophotometric approach to as a detector, you have some information coming from the position of the components in the 2D map. And the other example, for example, again in the lipid area, when we do fatty acid methylester, so we have a transesterification of the lipids. Again here, very important comprehensive GC for food analysis. They are containing lipids because you have separation according to non-polar columns, so according to the number of carbon of the fatty acid in the first dimension, but in the second dimension you have polar column, so you separate the fatty acid according to the polarity. So in this case you have a very important separation because you can get number of carbon in the first dimension, number of double bonds in the second dimension, but also the first dimension is influencing the separation of the where is located the first double bond in the fatty acid. So with the position you can know exactly the nature of that fatty acid. So it's very, very important. And the other field of application in the last years is also the coupling of comprehensive GC with the triple quad. So again, we have a very nice separation of the contaminants, but they are transferring to the second dimension. We have a better separation, then they are transferred to the MS where we have MRM approach, and so we have a very clean 2D chromatogram because we see in the chromatogram only the peak. They have that transition in the MS. So it's a kind of pre-purification with chromatography, and as I said before, in this case, we transfer the components from the first to the second dimension, and from the second dimension to the mass source, where we have a pure peak, so we can get a better signal to noise, so we have a better sensitivity. And when we use the cryogenic system, also we have, due to the peak focusing into the head of the second column, we increase the sensitivity.